family. I did the shit for the family. I did the shit for the family. Okay, Cindy bought 4 tins of tennis balls and emptied them into a basket. So the basket had 7 balls already. Altogether, she now has 27 balls. How many balls were in each tin? Okay, we're looking for the ball. How many balls were in each tin? So that's what we're looking for. It's going to be X, right? Total number we're looking for. Okay, so we know that she bought 4 tins of tennis balls, right? 4 tins of tennis balls, right? 4 times the tins of balls, and then there was already 7 inside. So in total, 27. Good. Now, with this equation, I can now find them, the balls that were in each team. So 4x is equal to 27 minus 7. So 4x is going to give me 20. Then I divide by that. So the value of x is going to be 5. So therefore, there were 5 balls in each team. In each team. Now, getting to this question number 4. You are given a graph. You are given a graph, right? So what you're gonna do here is, okay, I read the statement before answering the question. You read the statement, that's all it is. The graph above shows the number of fridges sold by a shop between January and June, 3 years back. Refer to the graph and answer the questions. So looking at the graph, these are the number of fridges. So here the fridges they've sold, right? Here's the value. Here's 5, here's 10, 15, 20. So they've never sold less than 5 fridges. People are buying the fridge. So first question is, how many fridges were sold in February? So I'm going to go to Feb. Here is Feb. Feb. Here is Feb. So let me see how many. So it's 30. We sold 30. That's in February. So the next question, between which 2 months did the sale of fridges increase? No, decrease. Between which 2 months did the sale decrease? Okay, so I'm gonna look at decrease. Decrease means that it was started at the top, then it went below. We're gonna look at the graph where it started at the top, then it went below. So here, if I look at this here, that is Feb. If we're going to March, started at the top, then it went below. So it's going to be between Feb and March. Then I'm gonna look again where there's another point again. At April, it was at the top, right? And then it went below. So between also again April and May. April. Wait. Yeah. April. April and May. That's when it was decreasing. If they asked the question if it was increasing, so you need to look at where it starts at the bottom and then going up. Because as you can see here, it's beginning below at 25, then it's going at the top. So between Jan and Feb, there was an increase, right? So yeah, so just check on those type of things there. How many more fridges were sold in May than in January? How many more? How many more? So we know that they sold many in May and they sold many in January, but the difference, how many more? So I'm gonna look at my graph. So in Jan and in May. So in Jan, they've sold 25. Then in May, they've sold 30, right? So more. So it's going to be in May 30 minus the one in Jan. So the difference is 5. So they've sold 5 more in May than in Jan. Okay, so as the data shown in the graph discrete or continuous. Okay, let us look at these terms. Right? If we say discrete, it means that I can count them using natural numbers, right? But for continuous, I cannot like I can also include irrational numbers. So for instance, if I'm looking at a data set of like concepts like weight, so with weight can be 5.3 kgs, right? 80, something. But if I'm counting people, it cannot be 5 point something. We can't have like, okay, let's say for instance, in a room, there are 4.3 people in the room. And brother, we look at you and say, this one, who's that 0.3 person? So that's like the discrete. The discrete is like elements counting, right? There's things that you can count, right? Discrete, but they cannot be continuous. Something that can be continuous again can be what is this? It can be things like something that can be continuous again can be stuff like temperature. You know, like it was like the past days was below I can say 8.308 degrees Celsius, sorry. This is continuous, right? But like you get what I'm trying to say. I know you got that the first time. Great. So my answer is discrete. Discrete, right? Right. Because items are not continuous. Items are not continuous. Items or right items are a whole. If we mean saying the whole like the whole thing, it cannot be decimal. Like whole numbers, right? Whole numbers don't have decimals. Whole numbers are integers, including 0. Yeah. Now let's get to this fourth question. 4.2. 3 marks. You are given an equation here. So complete the table. All you have to do is substitute the value of x. Here are the values of x. So you're gonna say y is equal to -2 plus 3, which gives you -1. So I have -1 here. Y is equal to -1 plus a 3, which is gonna give you a -2. Y is equal to a 0 plus a 3, which is going to give you a 3. Then y is equal to 1 plus a 3, which gives you a 4. So y is equal to 2 plus a 3, which gives you a 5. These are the coordinates. So we'll start there. You have -2 and -1. I mean, -2 and -1. X value -2, y value -1. Point here, -1 and -2. -1 and -2. I have 0 and a 3. 0 and a 3. Okay, I've made an error somewhere. Yeah. This is gonna give me negative 1. This gives me a 2. It's a positive 2. A positive 2. And then 3, 4, and 5. Yes. So this is a positive 1. This is a positive 1. Positive 1. Positive 1 here. Yes. Careful. You see, these are the errors that get when you write an exam, you get excited. Right? I got excited. I'm not gonna lie. So always be calm. Be calm so you don't make those errors. Good thing is I check. So every time you answer the question when writing the exam, go back to see, make sure that you won't have any errors that you made. And then it means that you have um -2 and a +1. So you have -1 and a +2. You have a 0 and a 3, then you have 1, 4, then 5 and 2. Okay, there's the straight line. There's the straight line. Yes. So that's what you've sketched in 4 marks.